Hello, in this lecture we will answer on two questions. In the first question we will find the side length of this square ABCD, and in the second question we'll find out the length of line segment AD that is equal to x. Okay, so we'll start with the first question. In the first question we have the drawing square ABCD. We know that line segment DE equals to 1 unit and the radius of this circle is equal to 2 units, and we want to find out the length of one side of square ABCD. So we know that the radius of this circle is equal to r, so we define that is equal to 2 units, so we define the radius of this circle as r, and r equals to 2 units according to what's given us in the question. So the radius of this circle equals to 2 units, and we define the center of this circle as point O, and we define the point of tendency of tangent AD with this circle as point M. So here we have the radius OM that is drawn to the point of tendency, that is to say the radius OM, it is drawn to point M, that is the point of tendency of tangent AD with this circle, and whenever you have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So if AD is perpendicular to MO, it means that this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay, so in the next step we will define the point of tendency of tangent AB with this circle as point L, and we will define the point of tendency of tangent EB with this circle as point N, and we will join points O and L together by a straight line. So here we know that line segment OL is the radius of this circle because of the fact that it starts from point O, that is the center of the circle, and ends at point L, that is the point of the circle itself. This is going to be the definition of a radius. So OL is the radius of this circle that is equal to 2 units. And here we have the radius ON of this circle that is drawn to the point of tendency, that is to say the radius ON, it is drawn to point L, that is the point of tendency of tangent AB with this circle, and whenever a radius is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So AB is perpendicular to LO. It means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. So here we know that ABCD is a square, and all the angles inside a square are right angles. So angle DAB will be equal to 90 degrees. So actually, in quadrilateral MOAN, we have 1, 2, 3 right angles. Again, in quadrilateral MOAN, this quadrilateral, we have 1, 2, 3 right angles. So I write it down. In quadrilateral MOAN, we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle MOL. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so we subtract 270 degrees from this equation, and we get that the missing angle MOL is equal to 360 degrees minus 270 degrees is equal to 90 degrees. So angle MOL is right angle, it is equal to 90 degrees. And this angle is a right angle. So actually we found out that all the angles inside quadrilateral MOL are right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. So we will relate to quadrilateral MOAN as a rectangle. Quadrilateral MOAN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle MOAN, this rectangle MOAN, we know that MO equals to AN. MO equals to AN. What we found out, we already found out that MO equals to 2 units. It is the radius of the circle. So we can write here that MO equals to 2, and from this equation 2 equals to MO equals to AL, we will derive that AL is also equals to 2 units. AL equals to 2 units also. So right here, that AL equals to 2 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we will get that ON equals to MA. ON equals to MA. But We have already found out that OL equals to 2 units. It is the radius of the circle. So we can write here that OL equals to 2 units. And from this equation, 2 equals to OL equals to MA, we derive that MA is also equals to 2 units. MA is also equals to 2 units, so we actually found out that when the other MOL is not a rectangle but a square, okay? So we can write down here that when the other MOAL is a square, because all of its sides are equal to each other. Okay. In the next step, I will present to you a new rule that is actually, it is not a new rule, but we call it rule number 2, that the lengths of two tangents from a common extreme point to a circle are equal. Okay, I have already mentioned this rule in the past, so I will not repeat on it. So we focus on the common external point E. At the common external point E, we have two tangents to this circle. The first tangent is tangent EM, and the second tangent is tangent EN. And according to rule number 2, the lengths of those two tangents are equal to each other. So that is to say, EM equals to EN according to rule number 2. So what is the length of line segment EM or tangent EM? EM equals to DA minus MA. Minus DE. Again, it is DA minus DE minus MA. I repeat again, from the drawing it is very easy to see that the length of line segment EM or tangent EM it is equal to DA minus DE minus MA. So we will define the length of one side of square ABCD as x. That is to say, DA equals to AB, and it is equal also to BC, and it is equals to DC. and all the sides of the square ABCD, they are equal to x according to our definition. I repeat again. DA equals to AB equals to BC equals to DC equals to x according to our definition. So here we get that EM equals to DA, that is x according to our definition, minus DE equals to 1 unit according to what is given as the question, D equals to 1 unit, minus MA equals to 2 units according to what we have already found out. So in conclusion, I found out that EM equals to x minus 1 minus 2 is x minus 3. So EM equals to x minus 3. You can write here that EM equals to x minus 3. But according to rule number 2, EM equals to EN. And we just right now found out that EM equals to x minus 3. So we can write here that EM equals to x minus 3. And from this equation, x minus 3 equals to EM equals to EN, we will derive that EN is also equals to x minus 3. EN equals to x minus 3. You can write down in the drawing that EN equals to x minus 3. In the next step, we will focus on the common external point B. From the common external point B, we have two tangents to this circle. The first tangent is BL, and the second tangent is BN. And according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, BL equals to BN according to rule number 2. What is the length of line segment BL? From the drawing, it is very easy to see that BL equals to AB minus AL. I repeat again, the length of line segment BL, it is equal to AB minus AL. So BL equals to AB, that is x according to our definition, minus AL, that is 2. So in conclusion, we found out that BL equals to x minus 2. So we can write down in the drawing that BL equals to x minus 2. BN equals to x minus 2. So according to rule number 2, BL equals to BN, but we just right now found out that BL is also equals to x minus 2. So I can write here that BL equals to x minus 2. And from this equation, x minus 2 equals to bl equals to bn, we will derive that bn is also equals to x minus 2. bn equals to x minus 2. So we can write here that bn equals to x minus 2. So in the next step, we will implement the Pythagoras theorem on the right triangle EAB, and by implementing the Pythagoras theorem on the right triangle EAB, we will find out the value of x. That is the line segment that we are looking for in this question. So we focus on the right triangle EAB. So we copy the right triangle EAB in a new page, and we'll implement the Pythagoras theorem on the right triangle EAB. AB equals to x according to our definition. What is the length of EA? The length of line segment EA, it is equal actually to DA minus D again. DA minus DA equals to EA. DA so repeat again, the length of line segment EA is equal to DA minus DE. So EA equals to DA equals to x according to our definition, and DE equals to 1 according to what is given as the question. So in conclusion, we found out that EA equals to x minus 1. And what is the length of the hypotenuse AB? The hypotenuse AB equals to x minus 3 plus x minus 2. So AB equals to x minus 3 plus x minus 2. So EB equals to x plus x is 2x, and minus 3 plus minus 2 is minus 5. So in conclusion, we found out that the hypotenuse EB of triangle EAB is equal to 2x minus 5 units. Angle EAB also, of course, it is equal to 90 degrees. It is one side of square AB, one angle of square, one out of 4 angles of square ABCD, that is a right angle, of course. So in the right triangle EAB, by PT is by Pythagoras theorem. Okay? This will be question number 1. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is EB, and therefore the square of the hypotenuse is EB squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to EA squared plus AB square. So EB equals to 2x minus 5. So EB square will be equal to 2x minus 5 square. And it is equal to EA square. EA equals to x minus 1, so EA square will be equal to x minus 1 square plus AB square. AB equals to x, so AB square is x square. So according to equation number 1, 2x minus 5 square equals to x minus 1 square plus x square. Here we will open the brackets on both sides of equation number 1 according to the algebraic identity that a minus b square equals to a square plus b square minus 2 times ab. So, and according to the algebraic identity that I mentioned, here 2x minus 5 square will be equal to 2x square, 2x square, that is 4x square, plus 5 square, that is 25, minus 2 times 2x times 5, it is minus 20x, that is equal to x minus 1 square. X minus 1 square equals to x square plus 1 square, that is 1, minus 2x plus x square. So according to equation number 1, we get that x square minus 20x plus 25 equals to, x square plus x square is 2x square minus 2x plus 1. So we subtract 2x square from this equation, equation number 1, and we get that according to equation number 1, 4x square minus 2x square is 2x square. We'll also add 2x to this equation, equation number 1. So minus 2x minus 20x plus 2x is minus 18x. And we will subtract 1 from this equation, equation number 1. So we get that 25 minus 1 is 24. That is equal to 0. Here we divide this equation, equation number 1 by 2. And we get that 2x square over 2 is x square, minus 18x over 2 is minus 9x, and minus 24 over 2 is minus 12. 0 over 2 is 0, so in conclusion, we got the quadratic equation x squared minus 9x is actually x squared minus 9x, and here 25 minus 1 is 24, so it is plus 24, and 24 over 2 is plus 12. Okay, so we got the quadratic equation that x squared minus x squared minus 9x plus 12 equals to 0. In this quadratic equation, the coefficient a equals to 1, the coefficient b equals to minus 9, and the coefficient c equals to 12. And the general formula for solving out the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay, so we put the data inside the formula for x, and we will find out the value of the values of x. So here x equals to minus b. b equals to minus 9, so minus b is minus 9, that is plus 9, plus minus square root of b squared. b is minus 9, so b squared is minus 9 squared, that is 81. Minus 4 times a is 1, and c is 12. So it is minus 4 times 12 over 2a. a is 1, so 2a is 2 times 1, that is 2. So here x equals to 9 plus minus square root of 81 minus 4 times 12 is minus 48 over 2. So actually found out that x equals to 9 plus minus 81 minus 48 is 33, so inside the root we left only 33 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to 9 minus square root of 33 over 2. 9 minus square root of 33 over 2 is equal to 1.62. So according to the first solution, we found out that x equals to 1.62. Okay, x equals to 1.62. According to our definition, here AB side AB equals to x. Okay, AB equals to x according to our definition. And according to the first solution of the quadratic equation, x equals to 1.64. X equals to 1.62. Here x equals to 1.62, but x that is equal to AB, it is greater than AL. And AL equals to 2 units. AL equals to 2 units and X is greater than AL. That is to say, X is greater than 2. From the drawing, you can see that X is greater than 2 units. So from the drawing you can conclude that X must be greater than 2 units. Okay, so X can never be equal to 1.62, that is less than 2 units, because X must be greater than 2 units. So we'll cancel this solution and we're left only with the second solution for X, that X equals to 9 1/4 of 33 over 2. Okay, so the solution to the question is that X, that is actually one side of square ABCD, is equal to 9 minus square root of 3, minus square root of 43 over 2. That is actually about 7.37. Is equal to 7.37 units. Okay, so here AB equals to BC equals to CD equals to AD, and it is equals to either 7.37 units, or we can present it also as 9 minus square root of 33 over 2 units. Okay, so we finished with the first method. We finished with the first question. In the next step, I will present to you the second question, and we will solve the second question in 2 different methods. Okay. So here, in the second question, we have in the drawing triangle ABC. Angle BAC equals to 120 degrees. Angle BAD equals to 60 degrees. Angle CAD equals also to 60 degrees. Side AB equals to A. Side AB equals to 2A. And BD equals to 2 units. And we want to find out the length of line segment AD that is equal to X. Okay? So, first of all, I will present to you a new rule that is actually the angle receptor theorem. It I already mentioned in the past, so we'll do it quickly. Now, what is the angle receptor theorem? According to angle receptor theorem, if we have triangle ABC, that could be any triangle. So this is triangle ABC. And we have the angle receptor AD. This is the angle bisector AD. So why line segment AD is the angle bisector? Because of the fact that it bisects angle BAC, or divides angle BAC into two halves. Each half equals to theta. So AD is the angle bisector. I write it here that AD is the angle bisector. According to angle bisector theorem, we'll get that AB over AC equals to BD over DC. Okay? In any triangle, if we have the angle bisector AD, then AB over AC equals to BD over DC. You can implement the angle bisector theorem in our triangle ABC. So here, as you can see from the drawing, AD is the angle bisector. Therefore, according to angle bisector theorem, in triangle ABC, we will get that AB over AC equals to BD over DC. So here, in our drawing, AB equals to A according to what is given as the question, AC equals to 2A according to what is given as the question, BD equals to 2 units also according to what is given as the question, and DC is the missing line segment. So in conclusion, according to equation number 1, we found out that A over 2A equals to 2 over DC. A over A is 1, so A will get cancelled, and we left only with 1 half, that is equal to 2 over DC. So here we'll cross multiply this equation number 1, and we'll get that DC equals to 2 times 2, that is 4. So DC equals to 4 units according to rule number 1. You can write that down here in the drawing that DC equals to 4 units. And in the next step, we will do a construction. In the first step, we will extend side CA of triangle ABC by a straight line. Okay, and in the next step, from point B, we will draw perpendicular on the extended line segment CA. So this angle equals to 90 degrees according to our construction. We will define the touching point of the extended side CA and the perpendicular from point B as E. So actually angle BEA equals to 90 degrees according to our construction. I'll write it down. angle BEA equals to 90 degrees according to our construction. Okay, this angle equals 90 degrees according to our construction. We'll focus on the green right triangle EAB. But here, before that, we actually extended side CA by a straight line. CA is one side of triangle ABC, therefore it is absolutely a straight line. So when we extended the straight line CA by a straight line, we got line segment CE. And when you extend a straight line by a straight line, the result must be a straight line. So the result, that is the result of the extension of CA by a straight line, is CE, and the result CE must be also a straight line. So you can conclude from it that CE is a straight line, or EC is a straight line. Line segment EC is a straight line, because when you extend a straight line by a straight line, the result must be a straight line. So EC is a straight line. We know that EC is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay? So if we focus on this side of the straight line EC at point A, then the sum of the angles must be equal here 280 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So at point A, so actually, if we focus on point A and the lower side of the straight line AC, so which angles we have here? We have 60 degrees plus 60 degrees plus angle BAE. 60 degrees plus 60 degrees plus angle BAE. In total, the sum of those four angles, the sum of those three angles must be equal to 180 degrees. According to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so we have here 60 degrees plus 60 degrees is 120 degrees plus angle BAE. In total, the sum of those two angles must be equal to 180 degrees. We subtract 120 degrees from this equation, and we get that the missing angle angle BAE is equal to 180 degrees minus 120 degrees, it is 60 degrees. So I found out that angle BAE equals to 60 degrees. So this angle is equal to 60 degrees. Okay, so we will focus on the green triangle BAE. On the green triangle EAB, the green right triangle EAB. We know that cosine 60 degrees equals to EA over BA. Cosine 60 degrees equals to EA over BA. So it is equal to EA over BA. BA equals to A according to what is given as the question. So cosine 60 degrees equals to EA over A. Cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2. So 1/2 equals to EA over A. We multiply this equation by A, and we'll get that EA equals to A over 2. So we can write here that EA equals to A over 2. And we'll continue to focus on the green right triangle EAB. On the green right triangle EAB, sinus 60 degrees equals to EB over BA. So it is EB over BA is A. So sinus 60 degrees equals to EB over A, and we know that sinus 60 degrees equals to square root of 3 over 2. So we substitute sinus 60 degrees by square root of 3 over 2, and it is equals to EB over A. Here we will multiply this equation by A, and we'll get that in conclusion EB equals to A times square root of 3 over 2. Okay, EB equals to A times square root of 3 over 2. So here EB equals to A times square root of 3 over 2 units. Okay. In the next step, we will implement the Pythagoras theorem on the big right triangle EBC. Okay. So I'll copy the right triangle EBC in a new page, and we will implement the Pythagoras theorem on the right triangle EBC. So this is the right triangle ABC that I copied from the original drawing. What is the length of side EC? From the drawing you can see that EC equals to 2A plus A over 2. 2A plus A over 2 is 2.5A. So here EC equals to 5 over 2A. EC equals to 5 over 2 times A, or 2.5A. EB, we just right now found out that EB equals to A times square root of 3 over 2, or square root of 3 over 2 times A, and the hypotenuse BC equals to 2 plus 4 is 6. So in the I triangle EBC, by PT, this is the abbreviation for Pythagoras theorem. We get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BC, so the square of the hypotenuse is BC squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to EB squared plus EC squared. So BC equals to 6, so BC squared is 6 squared, that is 36. And it is equal to EB squared. EB is square root of 3 over 2 times A, so EB squared is square root of 3 over 2 times A squared, plus EC squared. EC is 5 over 2 times A, so EC squared is 5 over 2 times A squared. So here we'll open the brackets on this side of equation number 2, and we get that according to equation number 2, (36) equals to square root of 3 square is 3, 2 square is 4, so it is 3 quarters times A square plus 5 halves squared is 5 squared, that is 25, over 2 squared, that is 4, times A squared. So here we actually found out that according to equation number 2, 36 equals to, we have 3 quarters plus 25 quarters is 28 quarters times A squared so 36 equals to 28 over 4 is 7. So in conclusion, we found out that 36 equals to 7A squared. We divide this equation number 2 by 7, and we get that according to equation number 2, A squared equals to 36 over 7. So here we take root out of this equation number 2, and we get that according to equation number 2, A equals to the square root of 36 over 7. The square root of 36 is 6, over square root of 7. So conclusion follow that A equals to 6 over square root of 7 units. So in the next step, I will present to you a new rule that is actually rule number 3. According to rule number 3, if we have triangle ABC that could be any triangle, and in triangle ABC, we have the angle bisector AD. Here AD is angle bisector because it divides angle BAC into two halves. Each half equals to theta. Okay? According to rule number 3, we get that AD squared equals to AB times AC minus BD times DC. Okay, I repeat again, in triangle ABC that could be any triangle. If we have the angle bisector AD, then AD squared equals to AB times AC minus BD times DC. We can implement the angle bisector theorem in triangle ABC. Why? Because triangle ABC has the angle bisector AD. Okay, so I'll copy triangle ABC in this page and we'll implement rule number 3 in triangle ABC. I repeat again, because of the fact that triangle ABC has the angle bisector AD, that is the reason that we can implement rule number 3 in triangle ABC. Here AD is the angle bisector that is equal to x, according to what is given as the question. BD equals to 2 and DC equals to 4. AB equals to A according to what is given as the question, and AC equals to 2A according to what is given as the question. So the implementation of rule number 3 in triangle ABC will be this will be question number 3. AD squared equals to AB times AC minus BD times DC. Okay, so here AD equals to x, so AD squared is x squared equals to AB is A and AC is 2A minus BD is 2 and DC is 4, so 2 times 4 is 8. So in conclusion, we found out that according to equation number 3, x squared equals to 2 times a squared minus 8. So according to equation number 3, x squared equals to 2 times, and a squared equals to 36 over 7 minus 8. 2 times 36 is 72, so I write it down. We get that according to equation number 3, x squared equals to 32 over 7. We'll multiply 8 by 7. We'll multiply minus 8 by 7, and then we divide it by 7 in order to have a common factor in this expression. So minus 8 times 7 is minus 56 over 7. 72 minus 56 is 16 over 7. So in conclusion, we found out that according to equation number 3, x squared equals to 16 over 7. We take out of this equation number 3, we find out that x equals to the square root of 16, that is 4 over square root of 7. So in conclusion, we found out that x equals to 4 over square root of 7 units. So in terms of numbers, it is equal to 1.51 units. Okay, so the answer to the question is that x, the line segment that we are looking for, that is also equals to AD, it is equals to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. So it's here, x equals to 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay, so we finish with the first method. In the next step, I will present to you how to find out the length of line segment AD that is equal to x according to the second method. Okay. In the second method, we define angle ADB as theta. BC is one side of triangle ABC, therefore it is a straight line. So if angle ADB equals to theta and BC is a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees, it means that angle ADC must be equal to 180 degrees minus theta. So in the next step, I will present to you the law of sines. So if we have triangle ABC, that could be any triangle. This is triangle ABC. The length of side BC equals to A units. The length of side AC equals to B units. And the length of side AB equals to C units. Then, according to the law of sines, we get that A or sine A, here capital A is the size of angle BAC. It is equal to B over sine B. Again, here capital B is the size of angle ABC, and it is equal to C over sinus C. Capital C is the size of angle ACB, this angle. So in any triangle, according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. We will implement the law of sines in triangle ABD. In triangle ABD, according to the law of sines, we get that A over sinus theta equals to 2 over sinus 60 degrees. In the next step, we will implement the law of sines in triangle ADC. So according to the law of sines, in triangle ADC, we will get that 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. Okay? I'll repeat again. 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. We have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta. So we can substitute sinus 180 degrees minus theta in this equation, equation number 2, by sinus theta. We'll do it now and we'll get it according to equation number 2. 2A over sinus 180 degrees minus theta is sinus theta. And it is equal to DC over sinus 60 degrees. According to equation number 2. But according to equation number 1, A over sinus theta equals to 2 over sinus 60 degrees. That is to say, we can substitute a over sinus theta in this equation number 2 by 2 over sinus 60 degrees. We'll do it now and we'll get that according to equation number 2 times a over sinus theta according to equation number 1 is 2 over sinus 60 degrees, and it is equal to dc over sinus 60 degrees. So here we have sinus 60 degrees on both sides of equation number 2, so sinus 60 degrees will get cancelled, and according to equation number 2, we found out that two times 2 equals to dc. That is to say, according to equation number 2, we found out that dc equals to 4 units, exactly as we found out in the first method. So here we can write down that dc equals to 4 units. In the next step, we will implement the law of cosines in triangle ABC. I've already mentioned the law of cosines in the previous lectures, so I'll repeat on it quickly. The law of cosines is true in any triangle. So if we have a triangle ABC, that will be any triangle. This is triangle ABC. Angle BAC equals to theta. The length of side BC is equal to 3 units. The length of side AB equals to A units, and the length of side AC is B units. So according to the law of cosines, we'll get that cosine theta equals to A square plus B square minus C square over 2 times A times B. I'll repeat again, in any triangle, cosine theta equals to A square plus B square minus C square over 2 times AB. So we can implement the law of cosines in triangle ABC. So we copy triangle ABC in this page, and we'll implement the law of cosines in triangle ABC. This is triangle ABC. AB equals to A units, AC equals to 2A units, angle BAC equals to 60 degrees plus 60 degrees is 120 degrees, and side BC equals to 2 plus 4, that is 6. So in triangle ABC, according to the law of cosines, the implementation of the law of cosines in triangle ABC will be that cosine theta This will be equation number 3. Cosine theta, cosine 120 degrees equals to a square plus b square is plus 2a square minus c square. C square is bc square, that is 6 square, that is 36, over 2 times a times b is 2a. Okay, and we know that cosine 120 degrees equals to minus 1/2. That is equal to 2a square is 4a square, 4a square plus a square is 5a square, minus 36 over 2a times 2a. Here we have 2 on both sides of the equation number 3, so 2 will get cancelled. In the next step, we will multiply this equation number 3, and we get that here a times 2a is 2a square, so it will be 2a square times minus 1 is minus 2a square. So we get that according to equation number 3, minus 2a square equals to 5a square minus 36. Here we will add 36 and also 2a square to this equation number 3 simultaneously, and we'll get that 5a square plus 2a square is 7a square, that is equals to 36. So here we'll divide this equation number 3 by 7, and we'll get that a square equals to 36 over 7. We'll take root of this equation number 3, and we'll get that a equals to the square root of 36 is 6 over square root of 7. So I found out that a equals to 6 over square root of 7 units. In the next step, I will present to you a new formula to calculate the area of any triangle. So if we have triangle ABC, that could be any triangle. This is angle theta. The length of side AB is equal to A units, and the length of side AC equals to B units. Then according to the new formula, the area of triangle ABC will be equal to A times B times sinus theta over 2. I'll repeat again, in any triangle, the area of triangle can be calculated according to the formula that A times B times sinus theta over 2 equals to the area of the triangle. Triangle ABC, that could be any triangle. We will implement the new rule in our drawing. here from the drawing, it is very easy to see that the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC, because the triangle ABC consists of the two small triangles, and the area of the two small triangles equals to the area of triangle ABC. So I write it down. According to the drawing, it is very easy to see that the area of triangle ABC, the big triangle ABC, it is equal to the area of triangle ABD plus the area of triangle ADC. And according to the new formula to calculate the area of any triangle, the area of triangle ABC will be equal to A times 2A times sinus 60 degrees plus 60 degrees is 120 degrees times sinus 120 degrees over 2. This is the area of triangle ABC, and it is equal to the area of triangle ABD. The area of this triangle, triangle ABD, it is equal to A times X times sinus 60 degrees over 2. Plus the area of triangle ADC. The area of triangle ADC equals to X times 2A times sinus 60 degrees over 2. Okay, so here we have 2 on both sides of the equation, so 2 will get cancelled. We know that sinus 120 degrees equals to sinus 60 degrees. So sinus 60 degrees will also get cancelled. And we have A on both sides of the equation, so A will also get cancelled. And what is left from this equation after we cancelled all the variables here? What is left is actually, in this side of the equation we have 2A that is equal to x plus 2x, x plus 2x, x plus 2x is 3x, that is equal to 2a. So if I know that 2a equals to 3x, we divide this equation by 3 and we get that x equals to 2 over 3a. X equals to 2 over 3a, and we have only found out that a equals to 6 over square root of 7 units, so x equals to 2 12 times a, and a is 6 over square root of 7 units. Here 6 over 3 is 2, and 2 times 2 is 4, so it is 4 over square root of 7 units. So in conclusion, we found out that x equals to 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. We finished with the second method, so in the next step I will summarize the lecture. We'll start with the first question. In the first question, we have square ABCD. We know that the radius of this circle is equal to 2 units. and we know that the short line segment D equals to 1 unit, and we want to find out the side length of square ABCD. Okay, so we define the center of this circle as point O, and here we join points O and M together by a straight line. OM is the radius of this circle because it starts from the center of the circle and ends at point M, that is a point on the circle itself. Therefore OM is the radius, that is equal to 2 units. So here we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AD with the circle, and whenever we have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So if AD is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. Then we join points O and N together by a straight line. OL is the radius of this circle for the same reason. It starts from the center of the circle and ends at point L. This is a point of the circle itself. So OL is the radius of this circle. We have the radius OL that is drawn to the point of tendency. That is to say it is drawn to point L, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So if AB is perpendicular to LO, it means that this angle equals 90 degrees and this angle will also equal to 90 degrees. And we know that all the angles inside the square are right angles, that is to say angle DAB is a right angle, so in quadrilateral MOAL we have 1, 2, 3 right angles. Okay? In quadrilateral MOL we have 3 right angles, then the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actual angle MOL. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation. We found out that the missing angle MOL equals to 360 degrees minus 270 degrees, it is 90 degrees. So this angle is a right angle. Therefore, all the angles inside quadrilateral MOL are right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. So we relate to quadrilateral MOL as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle MOAL, its opposite sides they are equal to each other, that is to say MO equals to AL. MO equals to AL, but we have already found out that MO equals to 2 units, so we can write here that MO equals to 2 units, and from this equation 2 equals to MO equals to AL, we will derive that AL is also equal to 2 units. Okay? Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that OL equals to MA. OL equals to MA, but OL equals to 2 units, according to what we will find out, OL equals to 2 units. And from this equation, 2 equals to OL equals to MA, we will derive that MA is also equals to 2 units. Here, MA is also equals to 2 units. Here, MA is also equals to 2 units. So I actually found out that quadrilateral MOAL is not a rectangle but a square, because all of its sides are equal to each other. Okay, then I presented to you rule number 2, that the lengths of 2 tangents from a common external point to a circle are equal. And the common external point E, we have tangent EM and we have tangent EN. According to rule number 2, the lengths of those 2 tangents are equal to each other. That is to say, EM equals to EN. EM equals to EN according to rule number 2. And what is the length of EM? the length of EM is DA minus DE minus MA. EM equals to DA minus MA. So DA equals to so EM and what is the we defined the side length of square ABCD is X, so that is to say DA equals to AB equals to BC equals to DC equals to X according to our definition. Okay, so here EM equals to DA, that is X according to our definition, minus DE, that is 1 according to what is given as the question, and we have already found out that MA equals to 2 units, so we can substitute MA by 2. So in conclusion, we found out that EM equals to X minus 1 minus 2. X minus 1 minus 2 is equals to X minus 3. So we found out that EM equals to X minus 3. EM equals to X minus 3. EM equals to X minus 3. So from one side, EM equals to EN according to rule number 2. But from the other side, we just right now found out that EM equals to X minus 3. So from this equation, X minus 3 equals to EM equals to EM. To EN, we derive that EN is also equals to X minus 3. EN is also equals to X minus 3. And then focus on the common start point, point B. From the common start point B, we have two tangents to this circle. The first tangent is BL and the second tangent is BN, and the length of those two tangents are equal to each other, that is to say BL equals to BN according to rule number 2. Okay, here at point B, BL equals to BN according to rule number 2. What is the length of BL? The length of BL, it is very easy to see that BL equals to AB minus AN. Again, AB minus AN equals to BL. BL equals to AB minus AN. So BL equals to AB, that is X, minus AN, that is 2. In conclusion, we found out that BL equals to X minus 2. Okay, so from one side, BL equals to BN according to rule number 2, and from the other side, we just right now found out that BL equals to X minus 2. So from this equation, X minus 2 equals to BL equals to BN, we derive that BN is also equals to X minus 2. Here, BN is also equals to X minus 2. Then we implemented the Pythagoras theorem on the right triangle EAB. Okay, so I copied the right triangle EAB in this new page, and we implemented the Pythagoras theorem on this right triangle EAB. What is the length of EA? From the drawing, it is very easy to see that EA equals to DA minus DE. Again, DA minus DE equals to EA. EA equals to DA minus DE. DA equals to X according to our definition, DE equals to 1 according to what is given in the question. So in conclusion, we found out that EA equals to X minus 1. Here AB equals to X according to our definition. And what is the length of the hypotenuse EB? EB equals to X minus 3 plus X minus 2. Hypotenuse EB equals to X minus 3 plus X minus 2. X plus X is 2X, and minus 3 plus minus 2 is minus 5. So in conclusion, we found out that the hypotenuse EB equals to 2X minus 5. Then we implemented the Pythagoras theorem in this right triangle EAB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, so the square of the hypotenuse is AB squared, and it is equal to the sum of the squares of the perpendiculars, that is to say it is equal to A squared plus AB squared. So EB equals to 2X minus 5, EA equals to X minus 1, and AB equals to X. We squared all variables, and we got this equation number 1, and we open the brackets on both sides of this equation number 1, according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab. So 2x minus 5 squared will be equal to 2x squared, that is 4x squared, plus 5 squared, that is 25, minus 2 times 2x times 5 is minus 20x, and it is equal to x minus 1 squared. X minus 1 squared equals to x squared, plus 1 squared, that is 1, minus 2x, plus x squared. Okay, so here we have, according to equation number 1, 4x squared minus 20x plus 25 equals to 2x squared minus 2x plus 1. So first of all, we subtracted 2x squared from this equation number 1. So 4x squared minus 2x squared is 2x squared. Here we have minus 20x and minus 2x. So we added 2x to this equation number 1, and we got that minus 20x plus 2x is minus 18x. And we have 25 on this side of the equation number 1 and 1 on the other side of the equation number 1. So we subtracted 1 from this equation number 1, and found out that 25 minus 1 is 24. So in conclusion, found out that 2x squared minus 18x plus 24 equals to 0. We divided this equation number 1 by 2, and we got that x squared minus 9x plus 12 equals to 0. In this quadratic equation, the coefficient a equals to 1, the coefficient b equals to minus 9, and the coefficient c equals to 12. And the general formula for solving out the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So we put the data inside the general formula for x, and found out the value of x. So here x equals to minus b equals to minus 9, so minus b is minus 9, that is plus 9, plus minus b squared. B equals to minus 9, so b squared is minus 9 squared, that is 81, minus 4 times a is 1, times c is 12, so it is minus 4 times 12 over 2a. A is 2, so 2 times 1 is 2. So conclusion, found out that x equals to 9 plus minus square root of 81, and minus 4 times 12 is minus 84 divided by 2. So x equals to 9 plus minus 81 minus 48 is 33. So inside the root we left only 33 over 2. So here x equals to 9 minus square root of 33 over 2. This is actually the first solution that is possible for x. Minus 9 minus square root of 33 over 2 is minus 1.62. So according to the first solution, x, that is actually equals to ab, is equal to 1.62. But here al, that is shorter than x, equals to 2 units. So if al, that is shorter than x, equals to 2 units, it means that x must be greater than 2 units. X is greater than al, that is to say x must be greater than 2 units. So x must be greater than 2 units, and x that is equal to 1.62 is less than 2 units. Therefore this solution is an incorrect solution, because x must be greater than 2 units. So we cancel this solution, and we left only in the second solution, that x equals to 9 minus square root of 33 over 2 units, or in terms of numbers it is equal to 7.37 units. Okay, so we finished with the first question. In the next step, I will present to you the second question. In the second question, we have triangle ABC. We know that angle BAD equals to 60 degrees, angle BAC equals to 60 degrees, BD equals to 2 units, AB equals to A, AC equals to 2A, and we also found out the length of line segment AD that is equal to X. Okay, so first of all, I presented to you angle Westertol's theorem. What is the angle Westertol's theorem? In any triangle ABC, if you have the angle Westertol AD, according to angle Westertol's theorem, we get that AB over AC equals to BD over DC. So we can implement the angle Westertol's theorem in triangle ABC. For the triangle ABC, we have the angle Westertol AD. The angle Westertol AD bisects angle BAC into two halves, each half equals to 60 degrees. So therefore, according to angle Westertol's theorem, we get that here in triangle ABC, AB over AC will be equal to BD over DC. Again, AB over AC will be equal to BD over DC. AB equals to A, AC equals to 2A, BD equals to 2, and DC is the missing line segment. So here A over A is 1, so A will get cancelled. So this side of the equation number 1, we have 1 half, that is equals to 2 over DC. We cross multiply this equation and found out that DC equals to 2 times 2, that is 4. So DC equals to 4 units. Okay, here. Then we did the construction. We extended side CA by straight line, and then from point B we raised perpendicular to the extended CA. So this angle equals to 90 degrees according to our construction. And we define the touching point of the perpendicular from point B in the extended CA as E. Okay, so I repeat again that angle BEA equals to 90 degrees according to our construction. So here we actually extended the straight line CA by straight line and created line segment CE. When you extend the straight line by straight line, the result that is CE must be also a straight line. So we know that CE is a straight line, and we know that the sum of the angles on one side of a straight line must be equal to 180 degrees. So if you focus on the lower side of line segment CE at point A, in the lower side of the line segment CE at point A, the sum of the angles must be equal to 180 degrees. Okay, according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have here? We have here 60 degrees and 60 degrees and plus angle BAE. Total the sum of those three angles must be equal to 180 degrees. So 60 degrees plus 60 degrees plus angle BAE must be equal to 180 degrees. 60 degrees plus 60 degrees is 120 degrees. So 120 degrees plus angle BAE must be equal to 180 degrees. We subtracted 120 degrees from this equation and we found out that the missing angle BAE equals to 60 degrees. So this angle equals to 60 degrees. Okay. Then we focused on the green triangle, the green right triangle, triangle BEA. On the green right triangle, triangle BEA, cosine 60 degrees equals to EA over AB. Cosine 60 degrees equals to EA over BA. So cosine 60 degrees equals to EA over BA. BA is A, so substitute BA by A. And cosine 60 degrees is 1 half. So substitute cosine 60 degrees by 1 half. So in conclusion, we found out that 1 half equals to EA over A. We multiplied this equation by A and found out that EA equals to A over 2. So here, EA equals to A over 2. Then, in this again, EAB, we know that sine of 60 degrees equals to EB over AB. Sine of 60 degrees equals to EB over BA. So it is EB over A because BA equals to A. And we know that sine of 60 degrees equals to square root of 3 over 2. So we substitute sine of 60 degrees by square root of 3 over 2, and we got that square root of 3 over 2 equals to EB over A. We multiplied this equation by A, and we found out that EB equals to A times square root of 3 over 2. So here, EB equals to A times square root of 3 over 2. Then we implemented the Pythagoras theorem on the right triangle EBC. I copied the right triangle EBC in this new page, and we implemented the Pythagoras theorem on the right triangle EBC. So here, according to the Pythagoras theorem, BC square equals to BE square plus EC square. BC equals to 6, so BC square is 36. EB is square root of 3 over 2 times A, so EB square is square root of 3 over 2 times A square, plus CE square. CE is 5 halves times A, so C square is 5 halves times A square. Open the brackets here. Square root of 3 over 2 times A square is 3 quarters A square. 5 halves A square is 25 quarters A square. 3 quarters plus 25 quarters is 28 quarters. So we got that 36 equals to 28 quarters times A square. 28 over 4 is 7. So here we got that 36 equals to 7A square. We divided this equation number 2 by 7, and found out that A square equals to 36 over 7. We took out all of this equation number 2, and we found out that A equals to the square root of 36, that is 6, over square root of 7. Okay. Then I presented to you rule number 3, that is related to angle bisector. If you have this triangle ABC, that could be any triangle, and we have the angle bisector AD, then AD square equals to AB times AC minus DB times DC. Again, AD square equals to AB times AC minus BD times DC. We implemented rule number 3 in triangle ABC. We can implement it in triangle ABC because we have the angle bisector AD in triangle ABC. This is AD is angle bisector. So according to rule number 3, we get that in triangle ABC, AD square equals to AB times AC minus BD times DC. AD equals to X, so AD square is X square. AB equals to A, and AC equals to 2A. So it is A times 2A. Minus BD times DC is 2 times 4. That is actually minus 8. So here, X square equals to A times 2A is 2A square, 2 times A square minus 8. We have already found out that A square equals to 36 over 7, so we can substitute A square by 36 over 7. We did it when we got that X square equals to 2 times 36 over 7. 2 times 36 is 72. And we found out that X square equals to 72 minus 56 over 7. 72 minus 56 is 16. So in conclusion, we found out that X square equals to 16 over 7. We took out all of this equation and found out that X equals to the square root of 16 is 4, so X equals to 4 over square root of 7 units, so in terms of numbers it is equal to 51 units. We finished with the first method, then I presented to you how to find out the value of line segment AD that is equal to x according to the second method. In the second method, we defined angle ADB as theta, therefore angle ADC must be equal to 180 degrees minus theta. And then I presented to you the law of cosines. In any triangle, A over sinus A equals to B over sinus B equals to C over sinus C. We implemented the law of sines in triangle ABD. This is triangle ABD. According to the law of sines, we will get that A over sinus theta equals to 2 over sinus 60 degrees. This is equation number 1, and we implemented the law of sines in triangle ADC. According to the law of sines, we will get that 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. We have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta, so we can substitute sinus 180 degrees minus theta by sinus theta in this equation number 2. We did it and we got that 2A over sinus 180 degrees minus theta is sinus theta equals to DC over sinus 60 degrees. Here, A over sinus theta, according to equation number 1, equals to 2 over sinus 60 degrees, so we can substitute A over sinus theta by 2 over sinus 60 degrees from equation number 1. We did it and we got that 2 times A over sinus theta is 2 over sinus 60 degrees, that is equal to DC over sinus 60 degrees. We have sinus 60 degrees on both sides of the equation, so sinus 60 degrees will get cancelled, and we left only with 2 times 2, that is equal to DC. Here, times 2 equals to DC, so DC equals to 4. Then I presented to you the law of cosines. In any triangle, cosine theta equals to A square plus B square minus C square over 2 times AB. We implemented the law of cosines in triangle ABC, so I copied triangle ABC in this page, and we implemented the law of cosines in this triangle, triangle ABC. According to the law of cosines, we get that cosine 120 degrees equals to A square plus 2A square minus 6 square over 2 times A times 2A. So here cosine 180 degrees equals to 1/2. 2A square is 4A square, 4A square plus A square is 5A square, minus 36 over 2A times 2A. We have 2 on both sides of the equation, so 2 will get cancelled, and we're left only with minus 2A square equals to 5A square minus 36. We added 2A square and also 36 simultaneously to equation number 3. We found out that 7A square equals to 36. We divided this equation number 3 by 7 and found out that A square equals to 36 over 7. We took out of this equation number 3 and found out that A equals to 6 over square root of 7 units. Then I presented to you a new rule, a new way to calculate the area of any triangle. Triangle ABC that could be any triangle. The area of this triangle, triangle ABC, will be equal to A times B times sinus theta over 2. We implemented the new rule in our triangle, triangle ABC. Actually, the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. And again, the area of triangle ABC equals to the area of triangle ABD plus triangle ADC. The area of triangle ABC equals to A times 2A times sinus 180 degrees over 2. A times 2A times sinus 180 degrees over 2. The area of triangle ABD equals to A times X times sinus 60 degrees over 2. a times x times sin 60 degrees over 2, and the arm of triangle ADC equals to x times 2a times sin 60 degrees over 2. Okay, x times 2a times sin 60 degrees over 2. 2 will get cancelled here, and also minus 180 degrees equals to sin 60 degrees, so sin 60 degrees also will get cancelled, and we have a on both sides of the equation, so y also will get cancelled. And what is left after we cancelled all the variables in this equation? We have here in this side 2a, that is what is left. 2a equals to x plus 2x. X plus 2x is 3x, so 2a equals to 3x. We divided this equation by 3, and we got that x equals to 2 over 3 times a. A equals to 6 over square root of 7 units, so we substitute a by 6 over square root of 7 units. And we found out in conclusion that x equals to 4 over square root of 7 units, or in terms of numbers it is equal to 1.51 units. Okay, thank you very much.